Hi, my name is Austin, and in this video I will present my Lab 7 system, which includes a homegrown real-time operating system I developed in this course, and the high-level widget display application running on top of my OS. For hardware, I'm using the Texas Instruments TM4C Launchpad microcontroller, the Espressif 8266 Wi-Fi module, and the ST7735 LCD display. My application allows you to customize the display with various data, including weather, stocks, dates, and time zones. On startup, the Wi-Fi module establishes a connection with my home access point and illuminates the green LED. Next, I can add my time zone by running a command to fetch time using my IP address. As you can see, the application has retrieved the data by opening a socket to the web server and issued an HTTP GET request using web APIs. Next, I'll add a few more time zones. To see the list of time zones I've added, I can use the push button to toggle through the list. I can also add weather information by specifying the city. Lastly, I'll add the latest stock information for a few companies. And I'll toggle through the list again a little bit. If you don't like a particular widget that was added, it can be deleted. And the screen will update. When finished with the configuration, the last step is to enable auto scroll. This will automatically trigger the next widget after a few seconds, so you don't have to use the push button anymore. So next, I'll talk about how the code was implemented, specifically using my OS and the services that it provides. So the first thing I want to talk about, here I have heap init, which indicates that I'm using heap management service through my OS for dynamic memory allocation, and this is used for retrieving variable length network data. I also have some semaphores that I'm using. These are primarily used for mutual exclusion with networking requests and also for rendering widgets. I also have here some background threads. So this is a push button thread that's used to update the display for going to the next widget, and also the periodic thread here that's used for updating things like the time information for time widgets. I also have these foreground threads that are used by my OS in my priority scheduling scheme, and these include the idle task. When nothing else is running, it goes into a low power state. I have the connect Wi-Fi task, which is used to connect to my access point. The interpreter task here that you saw was used for having a responsive interpreter for configuring the widgets. And I also have a display thread. Also of note, within my interpreter task, I have a few tasks that are launched, such as like the fetch date time widget. These are launched as separate tasks to make the interpreter thread more responsive. So that's it for my high-level application. I hope you guys enjoyed the presentation, and thank you for watching. Bye.